my name is Karine and I'm presenting my final project, and in this notebook I go over the goal of this project, which was to build and evaluate an object detection model which can detect cars and people in real world images. And I used a curated subset of Open Images Dataset from Roboflow. The dataset has two classes, car and person, and it's split into training images, validation images, and test images. So just to see the overview, the training set had 84% of the data set, 13% of validation set images, and 3% of the test images. And this is very important because training set has to be at least 80% to 90% of the data set, and the validation set is between 10 to 20%, and test is even lower, maybe 10 to 5%, but mostly 10 to 20% of the data set should be test. And this is because the training, when you train more, you get better results when testing and validating the data set. So in this project, I wanted to predict two classes and the bounding boxes of each object in an image. I ran these two cells to see the number of validation count, testing count, and testing count. So this model used and implemented in PyTorch, and it supports transfer learning through Ultralytics. And I use YOLOv8 N, and the N is nano, which is lightweight and suitable for my laptop because it runs on CPU. The model has 129 layers, which includes the convolutional layers, activation layer, and detection heads, and it has 3.1 million parameters, which seems like a big number, but in deeper models they have 50 plus million parameters. And I think this 3 million parameters is good, and it's lightweight for the CPU that I'm using. The model trained on the image size of 6040 by 6040, and I trained 20 epochs. So I trained for several epochs, 20, while monitoring the loss curves, learning behaviors, and performance on validation data. And for the validation, I used precision recall curve. I used the F1 confidence curve, precision confidence, recall confidence. And with the precision recall curve, the car class has the precision recall of 0.99, which is 99%, meaning the class is nearly perfect for the precision and recall. And the person class performed moderately with 58% precision recall, and I think this is because of the crowding and occlusion in the dataset images. As we can see, when we view the images, most of the images of people are crowded. But for cars, we only have one car, 2 maximum. So due to that, the precision recall for cars is lower because of the crowdness and occlusion. But overall, the mean average precision for the both classes is 79%, which shows strong performance considering the computation limitations. I also analyzed the confusion matrix to understand which classes were most or often missed, and car class was person class was mostly missing. It fell under the background, which is missed images. So in this section, we'll see the predicted bounding boxes for each validation set. So for instance, here we have 75% prediction for person, and in this crowded we have 0.25. We have all sorts of precision, but this one is almost 93% because it's only one car, and the shape of the car is the model recognizes very well. I also went ahead and created a Gradio demo interface, and I'm gonna upload some of the images. And before I do that, I want to explain that I am using a notebook browse because my kernel, I couldn't find any kernel, and I've tried to fix this, but maybe after, and I wasn't able to do this, so that's why I'm using the Jupyter notebook on the browser, which works perfectly fine. So I will upload a picture, and in this Gradio demo you can increase or decrease the confidence threshold, and I tried with 1, 0, and I found out between halfway is pretty good. And there we go, 60% and 91%. So this the cars are detected very well. And let's try with something else. People. See how game. It could not detect on the background, but on the foreground it's doing pretty well, above 0.5. And when I decrease the threshold, I get 0.49. So I also tried with an image that is not a car or a person, this animal, and see how the model does. And it detects it as a person with 54% confidence, which is not so good for the person class. And again, I think it's because the images used in the dataset for people were not very clear, a lot of crowding and occlusion. So this model performs extremely well on the car class, but it does moderately or averagely on human, because the human appearance varies and the clothing and the scale of the images were smaller in some images. So if I were to do this again, I would use more data set or images for people, and also train on more epochs on a GPU instead of a CPU. And I will also detect both classes in one images instead of just one one class in one image. So overall, this project is, this model is not so bad, because at the end it's 79% accurate. Thank you for learning with me.